Welcome all my dear student of TYBSc physics class. In previous lecture we studied trapezoidal rule, method for trapezoidal rule, example of trapezoidal rule. Then we also studied algorithm and flow chart of trapezoidal rule. Now if you studied in detail all these parameters, then you can easily develop a program to find the value of integration using trapezoidal rule. For that purpose, when we are going to develop a program or when we are going to prepare a program to find the value of integration using trapezoidal rule, at that time the program is very simple, but you have to include some important files to the current path from C library, and that files are nothing but standard input output files, header file, then Cuneo header file, then math header file. All these files should be included to the current path. Then we have to also define the function f of x in bracket 1 minus x into x square root. Okay. Then we are going to write the main program, and it begins from void main. Okay. In the body of void main function, first of all we should have to declare all the variables which we are going to use in our program, and that all the variables are nothing but floating type, that is real number. And for that purpose, float x0, xn, which are the lower and upper limit of the integration, then h, then s1 is another variable, s2 is another variable, and these variables should be initialized at the beginning. So here s1 is equal to 0, s2 is equal to 1. Like this we can declare and initialize the variable. We are also going to declare one more variable which is floating type, and that is nothing but I, and last variable floating type variable x. We should have to define two integer type of variable which are nothing but I and n. N is nothing but number of steps for the trapezoidal rule. Okay. Now after then we are going to use the clear CLR function for clear the screen. Then we are going to enter three values when program is executed. After then we are going to enter three values through keyboard, which are nothing but lower limit of the integration, upper limit or limit of the integration, and number of steps to be performed. And these values are entered and scanned by the computer by using these functions. First value, we are going to enter the value of x0. For that purpose, this printf function is used. That value should be scanned or read by the computer. For that purpose, this scanf function is used. And then we are going to enter the upper limit, which is nothing but xn, and that xn should be provided to the computer by using this printf function. After then, that value should be read by the scanf function. For that purpose, this function is used. Okay. Now we are going to enter the value of number of steps, and these steps are nothing but n. So we are going to, so that value should be the number of steps which we want to provide to the computer for integration, that should be performed by this printf function. Then that number of steps should be written by the computer with the help of this statement. In this way, by using this statement, by using this three statement, we can provide value of lower limit, value of upper limit, and number of steps for the integration. Okay. After then, we have to find out the value of h, and that value is nothing but xn minus x0 upon 2, like this. With the help of this formula, we can calculate the value of h. Then we should have to find out the variable s is equal to s1 plus f of x0 plus f of x1. Okay. Now here also x0 and xn, not 1. Okay. By using this formula, we can calculate the value of xn variable. Then after that, we have to repeat the procedure for number of iteration or number of steps, and for that purpose for loop is used for I is equal to 1, then I is less than or equal to n, number of steps, n minus 1. Then we should have to increase every steps by 1. So this for loop is useful. In the body of for loop, we calculate the value of x. For that purpose, we add the variable x0 with I into h, or product of I and h is added to x0 and the result is assigned to x. Then we calculate another variable x2, and which is nothing but x2 plus f of x. That is what we added the function f of x with s2, and the result is assigned to variable x2. And after then we are going to calculate the integration, and for formula for integration for trapezoidal rule is nothing but h by 2 into in bracket s1 plus s1 plus in bracket 2 into s2. In this way we can calculate the value of integration by using trapezoidal formula. This is the trapezoidal formula. And after then we should have to print the result. For that purpose we use the function printf. The integration, the value should be, result should be on new line. The integration of the given function that is I is equal to percentage f, and value of I is stored in the variable I, which we are going to print or display with the help of this function. And last function, the result should be hold on the screen by using this function, and body of the main function is completed. When this program is executed, the message displayed on the, that is output of the computer, output on the computer screen is like this. First message displayed on the computer screen, enter the value of x0. Here the cursor blinks. Here if we type 0, then second message is displayed like this, enter the value of xn, that is upper limit. Suppose we provide this value 1 through computer. Then computer again asks to us, enter the value of n. Enter the value of n. Suppose we give the value of n is 10. Value of n means number of steps for integration. If there are 10 steps, then when we supplied lower limit as 0, upper limit as 1, and number of iteration or number of steps 10, then obviously computer execute the programs and give the output, that is last message, the integration of the given function is equal to I is equal to 1 point, this is 1, 0.77 first two digit, after then 6130. In this way, this is the integration of a given function. Okay. Now we are going to see the last article or point of this chapter and of this paper also, that is C program. After that our syllabus is completed. Okay. Last point is nothing but Simpson's 1/3 rule. Don't forget that you already studied Simpson's 1/3 rule at 12th science also and at FYBSc and SYBSc mathematics also. In the paper of mathematics of FY and SY, you also studied Simpson's 1/3 rule. If you compare the trapezoidal rule and Simpson's 1/3 rule, then you will find that there is a minute difference between these two rules. That means there is a minute difference in trapezoidal rule and Simpson's 1/3 rule. Again, in Simpson's 1/3 rule, we are going to consider a function y is equal to f of x. This function b or y of x, y is equal to f of x, be a function having interval x0 and xn, where x0 is lower limit and xn is upper limit, and the y is equal to f of x be a function having interval x0 and xn, equally spaced values of arguments x0 is equal to x1 is equal to x0 plus h, then x2 is equal to x0 plus 2h, like this. Xn is equal to xn by x0 plus nh. Okay. Now we have to find corresponding values of y, that is y0 is equal to f of x0, y1 is equal to f of x1, y3, y2 is equal to f of x2, and last yn is equal to f of xn. Okay. Now using Simpson's 1/3 rule, we can find the value of integration, and this integration is nothing but x0 xn y of f of y dx. Here x0 is the lower limit and xn is the upper limit. Formula is very simple, h by 3. H is the interval, then y0 plus yn plus 4 in bracket y1, y3, y5, y7, y9. All odd terms, even terms are taken here. Then or simply you can say that like this, plus yn minus 1. Okay. Then plus 2, and in bracket all even terms. These are the odd terms, y2, y4 plus yn minus 2. This is the formula for, or this formula is known as Simpson's 1/3 rule. Now we are going to see a simple example, and this example is very important for exam point of view. When we solve the example or when we study this example, then you can develop algorithm and you can draw flow chart and you can prepare a program for Simpson's 1/3 rule, because I told you that there is a minute difference between trapezoidal rule and Simpson's rule. If you studied or if you compare the examples, algorithm and flow chart of trapezoidal rule and Simpson's 1/3 rule with each other, then you will get the idea, and from that idea you can easily develop a program for Simpson's 1/3 rule. Okay. So here we are going to see the example. Example is very simple. In this example, we have to evaluate the integral whose lower limit is 2 and upper limit is 2. Lower limit is 0 and upper limit is 2, and function is just like this, 1 plus 1 upon 1 plus x dx. This is very simple. And we have to evaluate this integral by using Simpson's 1/3 rule and dividing it into 10 subintervals. Okay. So solution, in this solution x0 is equal to 0, xn is equal to 2, that is, this is lower limit, this is upper limit, and n is equal to 10, which is nothing but the subinterval. Okay. Then from this h is equal to xn minus x0 upon n. Okay. Now from this value we can calculate h is equal to xn 2 minus 0 upon 10. Okay. Sorry. We are going to change this value because same values 0 and 2 is used in trapezoidal rule. So here we are going to change the value of upper limit. Instead of 2, here we are going to consider the value of upper limit is 6. Okay. So here also we have to consider the change. Okay. Now when we solve this, then we will get 0.6. That means there are 10 intervals which are equally spaced values of arguments. Okay. So there is a difference between two interval is nothing but 0.6. Okay. Now we can calculate the function y is equal to f of x is equal to 1 upon 1 plus x for different values. We have to find the values of this function y for different values of x, that is, value of x is 0, 0.6, 1.2, 1.8, 2.4, 3.0, 3.6, 4.2, 4.8, 5.4 and 6.0. These are the, from this, these are the 10 subintervals, and we have to calculate the value of y, that is given function for different value of x, like this, x is equal to 0.6, x is equal to 0.1 and so on. And after then we have to tabulate the result in a table. Okay. Suppose here we use value of x is equal to 0, then 1 upon 1 plus 0 is nothing but 1. Then for x is equal to 0.6, then we have 1 plus 1, 1 upon 1 plus 0, 6 is nothing but 1 upon 1.6. Then calculate, make the calculation, and this is nothing but 0.65. In this way, for all the such type of, all the such value of x, there are different values of y, and these values are nothing but like this, which are tabulated in the table like this. So x, then y is equal to f of x. Okay. And last, for 0, 1, this is y0, then 0.6, then 1.2, 1.6, 2.4, 3, 3.6, 4.2, then 4.8, 5.4 and 6.0. This is the table for 10 sub intervals. Okay. So first, then 0. Okay. Here value of 1. Okay. Value of 6 is 0.625. This is y1. Okay. Then y2, y3, y4, y6, y7, y8, y9, y10 and y11. When you substitute the value of x as a 1.2 in this function, y is equal to f of x is equal to 1 upon 1 plus x. Every time you are going to consider the value like this 1.2, 1.6, 2.4 and the result will be like this 0.45455. Then next one 0.3571. Then 2.4 0.29421. 4. Okay, whatever. Then 0.25 for 3. Then for 3.6 0.217 something 21739. Then 4.2 0.1931. Okay. Okay, 19. Then 231. Then for y9, y10 and y11. For 4.8 the result will be like this 0.17241. Okay. Then last 0.15625 and for 6 this is 0. Okay, this is these are the values. If we observe the table, then it is found that as the value of interval goes on increasing, the function goes on decreasing. Okay. Now all these values are we have to put all these value in Simpson's 1/3 formula, and that formula is nothing but very simple, integral 0 to xn, x0 to xn, yx or y, here y dx h by 3 y0 yn plus 4 y 1 y3 y5 y7 y9 1 3 5. Okay. Then 2 y2 y4 y6 and y8. Okay. This is the very simple formula for given iteration. Now just substitute the value. What is the value of h? 0.6 divided by 3. Then substitute all the values from that table and simply solve this term. You will get the result is like this 1.948591. This is the final integration. When you substitute the value of y, y1, yn, y0, yn, y1, y3, y5, y7, y9, y2, y4, y6 and y8 from the table which we studied before few minutes ago. Okay. and substitute the value, calculate, solve the term, you will get this result. And if I hope that you understand the procedure, you can solve the problems. If you can solve the problem like this, then you can, and if you studied very well by trapezoidal rules, that means what I want to say, if you studied the example of trapezoidal rule and Simpson's rule, and if you study the algorithm and flow chart, and if you also study the C program which we developed in previous lecture, then I hope that you can easily develop the algorithm and you can easily draw the flow chart, and you can easily develop a program for or program to find the integration by using Simpson's 1/3 rule. I hope that you can do this. Okay. In this way we completed 100% syllabus